All right, so we're going to start on the, which side are we going to start on? I think this one right here, the one with grade and then minutes on homework. Okay? And so what we're doing here is we're comparing two sets of data. Two sets of data, right? We have a grade, and we also have minutes spent on homework. Okay? So two different variables here. One deals with a grade, right? What grade that particular student is in, and then how many minutes they spent on average, okay, this particular student spent on homework each night, okay, in those particular grades. All right, and we're going to graph this data, all right, because of course that's what we want to do with these kind of things, right? We're going to take a look at the graph. So you'll notice here that our graph has no labels on it, which is no good. So how should we maybe label this x-axis to start out here? What do you think we should put on that x-axis? The grade. I think it's a good idea, right? It is kind of like, you know, the first column or first row, I should say there. So typically we'll put that on our x-axis. Okay. And then for labeling this, how do you want to do it? Do you want to, how should we maybe count here on the x-axis? What do you think?
By one.
Count by fives, count by ones. Okay. I mean, we can do a lot of different options here. Count by tens, you say? Again, for the grade, look at the grades, though. I mean, we're not going to go, just count by 10 is going to be a good idea here if we're using the grades.
Count by 0.5.
Count by 0.5. What do you say there, Jackson?
Oh, for grade?
Yeah, for grade. Count by 1. Okay.
I was counting by 1, but I did everything square.
Ah, okay. So that's really then counting by 0.5 if for every square, then, is what it would be, right? Half for every square.
Then on the other side of it, same thing, kind of like 10.
Okay, I got you. Yeah. So for the grade, you have some options here, right? We can really spread it out because we have so many, you know, little tick marks there, right, that we could do. We could probably fit in by counting every other block instead of every block. So it's really your choice here, okay? Your graph's going to look a little bit different depending on whether you count by 1 every block or 1 every other block, okay? I think I'm going to count 1 every other block, okay? So I'll start with 1 there, then 2, 3, 4, 5, 6, 7, 8, and then 9. Okay? So something like that. And then, yeah, on the y-axis, what are we going to label that then? The number of what?
Minutes on homework.
Minutes on homework. Maybe. Number of minutes on homework, and this is remember these were an average for that grade too. Okay, so it's not like they spent that much every single night. Some nights maybe more, some nights maybe less, but it's an average. And we wanted to count by what here? What do you want to count by on this one? Tens? Okay, so we want every block to count as a 10. We could do that. I might do every other block be 10. So I'll probably start with like, so I'll start with like, so really it's every block's going to be 5 for me. So 5, then 10, 15, and then 20's there, and then 30, and then 40, 50, 60, 70, and then 80. And I think 80 is the highest we have to go, right? Yep. Okay. Sorry, that's a mistake there. All right, so go ahead, plot the data. Okay, go ahead, take what you got right there in your table and plot your data points. Okay, plot your data points. Should we connect these data points? Probably not. Yeah, probably not. Okay, so don't necessarily connect them. Okay, we are going to be looking at a relationship, but don't necessarily connect them. So go ahead, plot those data points. Okay. And I'll do the same. Maybe I'll do it in a different color. relationship might this be? Okay, maybe exponential. What else might it be? Linear. Do you think it's possibly quadratic at all? Why not quadratic? Yeah, we don't see it like decreasing and increasing here, right? We only really see it increasing. So it could, you may be able to get a quadratic equation to fit it there, but it's hard to tell. Okay, it's hard to tell. So if we read here in the following directions, okay, you'll see that it's kind of like asking us to, well, it's kind of assuming what? When it asks the question, what is the slope of your line? And that's supposed to be the y-intercept, not the y-intercept, but the y-intercept. I'll scratch that out here. Okay. The y-intercept, the type of correlation. Okay, we'll talk about that here in a second. Okay. What do you think we're really going for here? What type of shape is it? With the questions they're asking here, the slope of our line, the y-intercept, okay, what kind of regression is that going to be? Is it going to be exponential regression? No, right? Exponential regression, you can't talk about the slope of your line if you're doing an exponential regression, because exponential is not a line, it's a curve, right? So we're probably going to have to do what kind of regression here? Not exponential, but what? Quadratic wouldn't give us a line. So linear, that's right. So how to do linear regression? We're going to go to our calculators. Okay, press the stat button and edit. Okay, we'll have to clear out our data from the warm-up there, and we'll go ahead and just type it in like we see it from their table there. So type in 1 through 9 in your L1, right? And then type in the matching y values into your L2. Okay. And again, please type accurately, or else you will get your answer will be thrown off there. Okay. Okay. All right. Anytime we type something into stat, we then press what? Stat calc. And then number 2. Well, we could use number 2 if we wanted the statistics, like the mean, median, mode kind of stuff. But we don't want that. We want linear regression in this case. We want the curve or line of, or in this case, a line of estimate. So we'll hit enter. Okay. X list is in L1, yes. My Y list is in L2, yes. Frequency list, that's not a thing. We don't have to worry about that. We're not going to worry about storing it either. We'll just have it calculate. Okay? So there's our equation, and let's go ahead and, well, let's see here. It says to identify what is the slope of our line. So what is the slope of our line according to this? We'll say 8.4. Yeah, let's see. Does it say what to round to? It doesn't. So let's just do 8.4. Okay? What's the y-intercept of our line according to this? Negative 5.4. Good. Okay. Now, I want to be careful here. Type of correlation. So correlation, it doesn't refer to the shape of the graph necessarily, right? So that's regression, right? So we have exponential regression, linear regression, quadratic regression, all that stuff. Correlation refers to the trend of the data. Okay? What happens to our data as the grade increases? What does it look like is happening to the number of minutes? It is increasing. Decreasing 1 point. Are you sure you plotted the correct point there? I would say check your work, because I don't think mine all increased.
Oh wait.
I think you maybe misgraphed something. Yeah. Yeah. But yeah. So overall, though, it is it's a positive correlation here. Now, we can be even more specific about what kind of correlation we have based off of this value r, okay, that we can come up with. Okay, now you'll see here when I did my linear regression, okay, I didn't get, there's actually some extra numbers I can get here. Let me just show you how to do this. I think so. There's this thing called the correlation coefficient. Okay, why? Hold on. The correlation coefficient helps us to determine how strong of a relationship there is between the two variables, okay, or at least how good of a predictor one is of the other and stuff like that. Okay, so how are we going to find those? Well, you have to do a little more button pressing on your calculator here. You're going to press the second button, second, and then 0. Okay, second 0 gets you to a screen called the catalog screen, and the catalog screen has every single command in it in alphabetical order that the calculator does. Okay, now if you want, you can scroll and keep scrolling and keep scrolling and keep scrolling until you get down to diagnostic, and we want diagnostic on. If you don't want to keep scrolling, I think if you press alpha D, it will jump to the D's. I'm not sure about that. Let me check on that. Alpha A. Yeah, it does. If you press alpha and then D, it'll jump down to the the letter D's there. And of course, we want diagnostic there, and we're going to turn diagnostic on. And you have to hit enter one more time. Okay, and now that we have diagnostic turned on, I'll press stat calc. I'll do my linear regression one more time here. It's diagnostic on in the catalog menu. Diagnostic on. You'll see I get some new numbers here. Okay, so yeah, R is our correlation coefficient. R squared is, oh, it's another coefficient. I forget what it's called, but R is a correlation coefficient. Diagnostic on, and then hit enter once you're on your home. Once it's on your home screen there, it should say done, and then you can go here. So this is a positive correlation, and since our R value here is 0.97, question.
Wait, you said done.
Now you want to redo your stat calc lin reg stuff, and it'll show up then. Okay. Yeah, go ahead. Since our R value is close to 1, that means we have a strong positive correlation there. Okay, strong positive correlation. R will always be I'll write that right here. Okay. The correlation coefficient is always between -1 and 1. Okay? Here, 0.97 is very close to 1. Okay? If R is greater than 0.8, that means it's a strong correlation. If R is less than 0.5, that means it is a weak positive correlation there. Okay? Weak. And I think I have that written down there right. I'll have to check on that to make sure. This seems a little strange to me still there. Because what happens if it's like 0.6 or 0.7, right? Then I guess it really is going to depend on your it depends on what your data is and stuff like that too. Different like disciplines have different kind of like standards for what is strong and what is weak. Okay, but we'll just use this. So if it's greater than 0.8, we're going to call that a strong correlation. If it's less than 0.5, we'll say it's a weak positive correlation. And then if it's between those two, we'll just say it's a positive correlation. That's it, not strong or weak. Okay? All right. So that's a brief thing. And again, the correlation coefficient just tells us how strong of a predictor the two data points are for one another. So that's pretty good. 0.97. It's pretty close to a linear relationship, right? If it was 1, it would be exactly a linear relationship. Okay. Anyway, that's what it should be. Yeah. Okay. The equation then, that's easy enough. It's just putting together the two pieces here. So 8.4x plus the -5.4. Okay. Oh, and that, I think I see what's going on here. All right, we're not going to worry about, we'll just use the linear regression thing. I think it wanted us to come up with an equation on our own. We'll just use the linear regression. We don't have to worry about doing it by hand yet. Okay. So we're just going to use our linear regression. Because again, I think what they wanted us to do there was to I think they wanted us to come up with our own equation, but we'll just use this. Okay, so how much time should be expected to spend on homework in 12th grade? All right, well, what can we do here with our linear equation? Plug it into, for which variable? For x, right, because x is the grade, right, and then y will give us the amount of time. So we'll say y equals 8.4 times 12 plus negative 5.4. Okay, 8.4 times 12 plus negative 5.4. Okay, 95.4. 95.4. And that is a number of what? What's the units here, folks?
Homework?
Yeah, minutes on homework, yeah. Minutes spent on homework. On average. Wow, 95.4 minutes. You know how much that is in hours? It's like an hour. It's over an hour and a half on average for your homework in 12th grade. I know some 12th graders that is not the case for. But I know some 12th graders that could be the case for, too. Okay, it really depends. Okay? Questions on any of that? All right, so let's turn the page here. I'll help you guys get started on this next one, and then I'll have you guys finish it off just like we did there. Okay? So let's see what we've got here. So turning the page. Is anyone still looking at this, what I got right here? Yes, it looks like so. Okay, I'll hold off on a second here. But go ahead and turn the page and familiarize yourself with what's there. We're looking at the value of a car.
Should it be connected because the car always has value? Or should it not be because they're not tracking it differently?
I would say because we're going to be looking at creating a line of best fit, I wouldn't worry about connecting the dots. Yeah, you don't need to connect them. The only time you really want to connect dots is when you're trying to show like, well, I mean, there are times when you want to connect the dots. When you want to show like trends over time, I guess, kind of thing. But we're going to come up with a relationship for our line of best fit. So, okay. Anyone else still looking at this page that I got up? We're good. Okay.
Are you doing this one all on
All around. I'll help you guys get started, and then we'll get into things. Okay. So we're looking at the value of a car for each year after its purchase in 2008. Okay, so you can see here are the years, okay, and then the value of that car in dollars over time. Okay, just by looking at the data right here, what kind of correlation are you going to expect? Positive or negative? Look at your data here. Negative, why? Because the values. Yeah, okay. Newer models come out. The car is more used, okay, so it's worn and stuff like that, okay. So this is going to be a negative correlation we would expect here. Let's go ahead and graph it, though, just to see. On our x-axis, what do you think we're going to label our x-axis? Year. I'm actually going to do it a little bit different here. I'm going to say years since, and then where we start counting. Yeah, since we're going to say years since 2008. So I'll count with year 0 here. And then I have to count all the way up to 2016. So I think I can do that by counting every other block. So I'll say here's going to be 1 year since 2008. That'll be 2009. And then 2, 3, 4, 5, 6, 7, 8. 8 years from 2008 will give me to 2016 right there. So I can stop at 8. If you want to keep going, you can. 9 and then 10. Okay? But I think this is a better way to go, years since 2008, as opposed to just a straight-up year, because you get some really big numbers if you start using the actual year there and stuff. How about here on the y-axis? What will its label be? What's the y-axis? Yeah, value in dollars. But yeah, that's a good question here, right? So if you look, right, we have all these are in thousands of dollars. So maybe instead of counting by just straight-up dollars, maybe we should just do it in thousands of dollars. So let's do that. Value. Thousands of dollars. Okay? Thousands of dollars there. So what does that mean? Well, $18,900 is what in thousands of dollars? Yeah, 18.9. And this would then be $16,500 would be what in thousands of dollars? 16.5, and then 15.2, and then 14, and then 12.3, and then 11.5, 10.6, 9.8, 8.5. Okay, those are all in thousands of dollars now. So let's see here. Maybe I will count by ones. I think I'm going to count by ones here. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17. Wow. 18, 19, 20. Okay. So just count by ones there. All right. So now I'll leave you guys the rest. Go ahead and plot the data and answer the rest of the questions down there. Okay. So go ahead, plot the data and answer the rest of the questions there. Okay. Plot the data, answer the rest of the questions. Okay, and I will do the same. I'm gonna wipe off this pen too. That's okay, I understand.
No, I swear.
You don't have her.
But that,
You have wait, is she a main person on your account? See, look. Look. John. It says Julia. John, you only have a Julia. You don't have a weird Jacker. No, you don't. Look. Just because it didn't set its name. Show me.
other questions? Yes. Chapter number.
He's insane. Quickly follow. At her base. Just pull up your fire app.
You can do that if you want to, yes, I would say, yeah. So yeah, y equals blah, 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 and then yeah, don't forget to look at your r to help you determine the type of correlation. Strong positive, weak positive, strong negative, weak negative.
They didn't block fire.
Alright, Libby, what's up? Yes.
Yeah, use Wi-Fi. Your friend in school.
The decimal point is, it's your choice what you want to do.
Minus attack plus res. Is kind of insane.
Okay.
Not gonna lie. I just don't know what the choice.
Yep, that's right. Oh, that means that you don't have the same number. You don't have the same amount of numbers in.
Wait, hold on, Dylan.
You don't have the same number of numbers in each list.
Jewel taken? Darn it.
See, so we need. Oh, okay. So if you're doing years since 2008, zero. So I can do that anyway.
People out of the way, he counters.
Okay, so now she
As an attack.
zero and it counts down.
Oh, it's
I did.
It's the solo thing.
You don't really
Oh my god. It looks good. I'm so high line.
Maybe. Maybe. Yes. Maybe.
Wait, he actually.
The first day I've seen you not here, like actual blood, I'm sure.
Well, last Monday, or was it Tuesday? Last Tuesday when we came back to school from like the 3-day weekend or whatever, it was like really hot in my room, first block, and I was like not gonna have that happen.
Freaking dumb.
So,
Or ones like that, and I tell you.
well, first of all, you started 0 because it's 2008 when you 0 and then 1 people left. So that's what I did. I started 0.
That would be amazing.
Okay.
Done. Done. This is the worst thing ever. What's the plus speed surge? Plus speed.
Give me like 1 or 2 more minutes here, folks. 1 or 2 more minutes to finish this up.
Limited.
1 or 2 more minutes here to finish up.
Dude, John, you wanna see something limited?
He's just not a good reader.
John, I got something limited for this.
I mean, like, with the
Here's your
tournament
limited.
power, when the tournament
And
power
then-
equipment, it becomes alright. It becomes
Limited.
decent, but because of
You still don't have her yet,
destruction,
John.
God, he, and twins. I mean, with God,
Gotta get on that
but
ground,
with
John.
God, destruction, and twins, he's taking that out. He's a bad unit. Like, no one else is over that.
When was the last time you went to a Herbs? You should give John some herbs. He's been coughing lately. Is it cough drop? It's fine. It's just
Yes.
cough drop. You're out of herbs. Would you like a herb? Sure. Eat up some herbs.
This one? Yeah.
Yeah.
It's got the answers on it, just heads up.
John, you can get an effect on divine knowledge.
No, you're good.
That's why I like it. It's insane.
We have a homework paper.
Thank you. Nope. Yep. Anyone else need more time? Are we good? Okay. So here's what your graph should look like. Okay. Now, just based off on the look here, right? Does that look like a strong or a weak correlation? Strong, right? Okay, it is very close to a line. Okay, you can almost just imagine a line here. Look how closely grouped that would be around a line that you drew right in there. Okay, so it's gonna be a strong a negative correlation. Okay, a weak negative correlation would look something more along the lines of like this. Okay, you might have it like. Okay, general trend downwards, right? So like a weak negative correlation looks something like this. It's a general trend downwards, but it's not tightly packed around one single line. There's a bunch of lines you could potentially draw there, right? So it wouldn't be as strong of a negative correlation. It'd still be a negative correlation, right? Because it's going down, left to right. But it's not a single line. It's kind of all spread out. This is going down, and it's very tightly packed around a single line, right? So that's why we're going to expect a strong negative correlation. In fact, when you do your line of best fit here, okay, I got y equals negative 1.2x plus 17.9, and my r value is negative 0.988. That indicates a strong negative correlation there, right? Your equation might be a little bit different than mine depending on how you set yours up. I plugged in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 into my L1, and I plugged in, my L2 of, the matching values right here into 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So I used years since 2008 for my X values and the value of the car in thousands of dollars, and that's what I end up with there. Okay? Then what's the expected value of the car in 2019? So that's the beauty of this, right, is that when you find a relationship that closely matches a line, you can then predict the value of the car into the future. You can predict the value of things into the future, which is the benefit of that, right, being able to predict the future using math. Okay? So here in this case, with this relationship, if the relationship continues, right, we would expect the car to be worth about $4.7 thousand, or in other words, $4,700. Okay? Again, we want to plug in 11 for X because 11 is the number of years since 2008, right? 2009 is 11 years from 2008 there, so that's why you want to put in 11 in for your X. Okay? Questions on any of that? No? All right. So, that's all I wanted to refresh our memory about today. What I'm going to do is give you guys your assignment here to work on for